In this video, I want to demonstrate a debugging technique that can be useful when trying to debug a program that has an infinite loop in it. First, let's look at the program that has an infinite loop. What it does here is generate pseudo-random numbers using a linear congruential operator. Here's basically how it works. We have the three constants a, c, and m, which we chose arbitrarily. Actually, I just copied them from Stack Overflow. Then we have an initial value for n. Let's define those. Now that we have those four values defined, we can keep generating new n's using this formula. Let's try that. Just say n is equal to a times n plus c mod m, and then I'll print n. And now I can do it again, and again, and again, and again, and again, and again. Those are what's called pseudo-random numbers. They are, of course, exactly determined and will be the same every time we run this loop, assuming we start with the same n that's equal to 55, but they look like they're basically random. So we generate those pseudo-random numbers, and then we call g with n mod 142. G is this weird function. Let's run the whole thing. It runs for a while, but now it stops. It stops, but we don't have the usual thing that we see when the program finished running. We don't have the in10 line here. This indicates that we are in an infinite loop. How to debug that? We can interrupt the program in Pyzo by saying shell interrupt, or simply pressing Ctrl-I. Done. Now we see in 10, and we actually can see where the program was interrupted. It was interrupted on line 8 inside G, where we're saying x times equals 11 minus n. At this point, you might kind of see what's going on, but let's actually do it in an organized way. What we can now do is we can say shell postmortem debug. That lets us see the state of the program just before it was interrupted. We can look at the values of variables as well. We can evaluate expressions and so on. Let's try to do that. X at this point is minus 2, and n is 12. You can try to evaluate this line and try to figure out, okay, so why is it that we're having an infinite loop here? So probably this while loop never terminates. Well, if you multiply x by 11 minus n, you get 2. If you multiply x by 11 minus n again, which is what's going to happen during the next iteration of this loop, you'll get minus 2. So you see, because 11 minus n is actually equal to minus 1, x is going to alternate between 2 and minus 2, but the absolute value of x, it's never going to get to 5,000 or above. It's always going to stay below 5,000, which means that this expression is always going to be true, and the loop is never going to terminate. How do we fix that? Well, the first thing to do is to say, okay, so how did we get there? Well, we know that n is equal to 2, but which n down here caused it? To figure that out, we can move further down the stack to see what was happening before. Let's see. So here at the very start, we called f. This is the call to the g, which got interrupted. We can check out the value of n here. The value of n is 52,126. That's the value of n that was causing the problem. Inside g, because we called it with 52,126 mod 142, n was different and was actually, like we saw, 12. Here though, n is this, and we might try to say, okay, so when is it happening? When does n get to be this number? There's a sophisticated way of doing this, but let's do it simply. Let's stop the debugging, and let's say if n is equal to this number, we want to stop and see what's going on here. So I'll just say print high and set a breakpoint here so that I can then go on and go inside G with the correct value of n. Let's run it. I'm pressing Control E. And now here we are. So we're not yet in the infinite loop, but we're about to enter the infinite loop because n is now equal to 52,126. This is why we entered the if loop and we're about to print high. Next, we can actually go inside G. And now this is the infinite loop. We know that that's gonna be the infinite loop. And if we haven't figured out already what was going wrong, we can trace it by looking at the values that S and X take, in particular that X takes. So let's do that. In order to do that, what we need to do is we need to say Tools Workspace. Here is our X, and let's just keep tracing. So X, like we said before, it alternates between 2 and -2, and the reason for that is because n is equal to 12. How might we fix it? Well, it sort of depends on what you wanted G to do in the first place. An easy fix would be to say, okay, we can't allow for n to be 12, and if you think about it, we can't allow for n to be 10, and we can't allow for n to be 11. Let's do that. We'll say if n is in 10 or 11 or 12, those are the values that would produce -1 or 0 or 12 for this factor, which would make sure that x is never going to grow past 5,000. Well, we might say print avoiding the infinite loop. And we might say return before we actually enter an infinite loop. Now, if we run the program and get rid of the breakpoint, we'll be all good. It'll, of course, run forever until counter becomes 5,000. Stop there for a while, but that's because it took it a while to complete the run. That's it.